All right, welcome back. So here is the data from our first spring experiment. We have masses. I put them in ascending order here. We did a 500 mass weight, and that stretched the spring 19.5 centimeters. The stretch, by the way, is called displacement usually. So we'll do this in a couple of different ways. First thing, it's a good idea to look at the data, see what it looks like graphically. So I'm going to ask Sheets here to make me a chart. And I want a scatterplot. All right, so those points line up quite nicely. Look at that. Not perfectly, but pretty nice. So part of it could be just user error. I didn't have the best ruler, and I was using my eyes, or you were using the camera to do that, but they line up pretty good. So we're just going to pick 2 points, like maybe the first point and the last point, and we're going to try to find the line, and then we'll ask the computer to find the line for us. So let's move this out of the way. So we need to find the rise and the run. And so the rise, that's going to come from the displacement. The run is going to come from the mass. So we have the mass run. We have the displacement rise. And so I want to just find the difference between the last point here and the first one. So that gives me a rise of 17 and a run 500 grams to 100 grams. So that's 400. And taking the rise over the run is going to give me the slope. So equals rise divided by run. So I get a slope of about 0.0425. And usually I take measurements like that to 1 or 2 decimal places more than the data. So here I have 1 decimal place, so maybe I would take it out to 0.04 or 0.043. It's only 1 decimal place more, so I'll just hold on to that. So that's the slope. Now, theoretically, we would predict the y-intercept to be 0, because if we don't put any weight on the spring, it's not going to get stretched. Okay, so then I think my model here is that the displacement is going to be equal to 0.0425 times whatever mass I put on there. I'll use a lowercase m. So I think that's my equation. So then I can use that to do my prediction for my cup. Now I can reverse this whole thing. If I flip the rise over the run or solve this for m, that'll give me a similar equation. So I can also come up with an equation for mass equals some number times the displacement. So I can reverse the relationship and guess what the mass of the cup is. So we got to figure out what that reverse slope is. So underneath here, I'm going to put inverse slope. And this is easy because the y-intercept is 0. If we have a different y-intercept, we have more work to do. I can show that another time. So I just want to take 1 divided by this number right here. So that'll just flip the rise over the run. That's going to give me 23.53-ish. Just to double check that, if I take 400 and divide by 17, that's going to be that same number right there. So that's my inverse slope. So here in my formula, I'm going to call it, for example, how about 23.53? So that's an alternative model here. Calculate the mass based on the displacement. Now, we found the displacement for the mystery cup was 13-ish. I thought it was a little more than 13. And so I can calculate by saying equals 23.53 times whatever I think the displacement was. And so that says if my measurements are accurate, the mass of the cup is about 300, a little over 300 grams. Right? I thought it was actually a little more than that. Maybe it was more like 13.2, and that takes it up to 310. So provided that my measurements are accurate here, and my weights are what I think they were, this should be a pretty good model for calculating the mass. So we've got that change in time, a change in displacement over mass, that's linear. But that's the computer to do a similar thing for us. So let's get our graph here. Zoom out just a touch. And let's see if I can fix that a little better. Oh, that'll have to do, I guess. Oh, well. So I need to edit this chart. I guess I'll have to zoom out one more time. Oh, I know what I can do. Bring it into its own screen. Bingo. All right. So editing this, I want to customize series so that I can have a trend line. And the trend line, I want to see what the equation is. So this says the slope should be about 0.0418, and then the y-intercept is -1. So we got to figure out what that means. I'll write those down. 0.0418. They're using an x, which is my mass, minus 1.01. So that could reflect error in my measurement, or maybe the way I set the spring. Most likely it's error in my measurement because I didn't have the best. All right, here we go. Best ruler. So alternative model. For the displacement, given the mass, is 0.0418 times the mass minus 1.01. So that would be, let's see, displacement. So no, I wasn't off by a centimeter. I guess the errors in reading this could throw it off that much. So that's kind of like a fudge factor there at the end. So we can try that and see what that predicts. So let's say I thought the cup was 13.2 centimeters for a stretch. Using the new model, I'll take 0.0418 times the displacement and then take away. Oh, no, I forgot to reverse that, didn't I? Need to solve this. So let's just do this again. So we can solve this algebraically. We would add the 1.01 to the other side. So that'll give me d plus 1.01 equals 0.0418 times the mass. And then to get the mass alone, I would divide by the 0.0418. So then I would have parentheses displacement plus 1.01, space in there to make it prettier, and then I would divide that by 0.0418. And that will calculate the mass for me. Back here equals parentheses displacement plus its fudge factor of 1.01 according to the spreadsheet calculation, and divide that by 0.0418. And that gives me a mass of 339.9, so about 340 grams for the cup. So realistically, my first model makes more sense, which was this calculation, because if there's no mass on the spring, there should be no displacement. However, there's room for error here, and so the computer used a fancy system for calculating a slope and a y-intercept here. And using that, I get a slightly different number. So there's different ways to make models. The better model here is probably the computer version, because I just picked the first and the last point. Why? Because they were the first and the last point. I could have picked a different pair. So the actual mass of the cup is 344 grams. All right, that's it for now. Fun with lines and experiments. Have a good day.